Let's add a couple of examples of abrupt climate changes along the way, and then we will try to look at the responses in agriculture and culture as well. As you see by now that even though we are talking about mainly climate and agriculture, we cannot talk about agriculture without societal responses to climate change, to wealth, to stabilized life of an agricultural community or society, and so on. So we have to then again come back to abrupt changes in climate that could have perturbed the agricultural evolution and societies seriously. Obviously, the poster child for an abrupt climate change has been the younger Dryas, where if you go back to 20,000 years ago and look at temperature evidences in deuterium ore here, derived from various lake and river sources from Kuriako and Greenland and so on, you can see that they all showed different kind of evidences. Obviously, younger Dryas was very much a northern hemisphere phenomenon, and you can see the warming here is coming into Holocene by this time as already. But if you look at Kuriako and GISP2 in temperatures, this is accumulation per year and this is a temperature here. So we were coming out of the last glacial maximum, and there was a blip as older Dryas, but the younger Dryas, which as we have talked about very much relates to somehow changing very quickly the global temperatures, or at least temperatures in the northern hemisphere, where the so-called Dryas flower, which grows in cold periods, reappeared. During the warming, it would have disappeared in the Arctic Circle because of the warming and the climate conditions they like. But this near glacial period called Younger Dryas is named after this flower that grows in cold conditions, and that became common in Europe during this time, which means Europe got much colder as well. And the big deal about this event, of course, is that you can look at many time series that are very highly resolved in time, and you see serious temperature drops in very, very short period, order 10 years or even less. Okay, so this scale is quite coarse, but you still see the rather abrupt drop in temperature of several degrees here before it slowly recovers and we get into the Holocene. This recovery is even slower, as we saw with the this accumulation recovery is even slower in terms of meters per year. Remember, during the cold times, atmosphere gets colder, snowfall rates gets reduced, because a very dry cold atmosphere doesn't hold much moisture. Entire global climate cools, and precipitation in general drops, dust amounts go up in the atmosphere, as we saw before, and so on. And temperature drop here, glacier surface temperatures dropped fairly severely as well, and recovered fairly rapidly, and then we have this fairly stable climate. So in terms of agriculture and society, we said that maybe the warming that had already started at the end of the glaciation was already driving Homo sapiens to at least mix some wild crops into their diet of foraging, hunting and gathering with foraging. Maybe some domestication of animals was happening, even though there is no solid evidence till the Holocene. But this abrupt cooling would have massively perturbed the attempts to domesticate plants and animals. But it's also possible that this drove cultural changes in terms of a shift to agriculture, because either the move or the extinction of many megafauna and source of food from wild animals would have probably affected how things evolved in response to the younger Dryas later on as well. So we've been kind of talking about it. The other thing that happened was much more recent in terms of abrupt change. The Laurentide Ice Sheet, which grew during the last ice age from 135,000 years ago to 21,000 years ago, which we have seen as marine isotope stages for the more recent period, extended into North America, Europe, Greenland, and so on, and it started to melt during the deglaciation from about 20,000 years ago to 10,000 years ago when it completed, but still some chunks were left. And one of the ideas of the younger Dryas, of course, is that as the glaciers melted and they carved out these great lakes and so on, and they created the terminal moraine island of Long Island here off of New York. Some meltwater was trapped behind a ice glacier wall that didn't melt like a local refugia, and at some point the water pressure got so large that the dam broke and released massive amounts of fresh water onto this region of Labrador Sea and Greenland, Iceland, Norwegian seas. Remember, this is where deep water formation happens, and the critical part of deep water formation is that the surface salinity is high and Gulf Stream brings a lot of heat, and that heat is picked up by the atmosphere, and a warmer atmosphere can hold more moisture, so evaporation would increase the salinity and cause deep water formation, the so-called North Atlantic deep water, which then flows south into the Southern Ocean and so on. And there is a return flow to compensate for the sinking, which is shown in terms of this complicated arrival of the Gulf Stream after separating from the coast, becoming the North Atlantic current, North Atlantic drift, Norwegian current, and of course becomes East Greenland current here, and so on. So these high salinity regions would have been affected. The more recent abrupt, so younger Dryas is very much related to those things. You can see the flow of pathways of meltwater flows in these yellow arrows as well, down into the Gulf of Mexico through Mississippi, north here into the Mackenzie and so on. And you also have complex circulations in the Arctic, drifts of glacier pieces that we talked about during the so-called Heinrich events, and large ocean atmosphere dynamics here. There's a loud wind noise, I hope it's not spoiling the recording, in the Labrador Sea, Baffin Bay, and so on. So the remaining ice, the glacier that melted, caused also what is now the Black Sea, in terms of inundating it from the Mediterranean side and making it into a sea, Black Sea, rather than just a freshwater lake or a brackish water lake. The other things that happened also we will come back to is the refugia that got formed. So this is the schematic representation of the distribution of major vegetation types and forest trees along a hypothetical transect from the Mediterranean to the Arctic Ocean during an interglacial here, during the last glacial maximum, and these are two key regions of how local moisture zones would have affected things. During the last glacial maximum, 3 occurrences in the LGM according to classical model of southern montane European refugia are shown in B. Current ideas about 3 occurrences in the LGM in both southerly and northern refugia are depicted here in C. Okay, so this is the transect going from the Arctic Ocean into the Mediterranean. So during the interglacial, you have certain forest distribution climbing into the mountain high latitudes, and then this is a Quercus ilex forest, this is a deciduous forest, boreal coniferous forest, birch forest, shrublands, and tundra transitioning into cold climates here. During the last glacial maximum, the cooling would have converted this into a steppe, a local montane zone, steppe shrub tundra here on this side, steppe tundra, polar desert the cold, dry ice would have created a polar desert and continental ice sheet, of course, which doesn't support vegetation. And the refugia here shown a steppe, local montane zone now with steppe, shrub, tundra. You can see the mix of various forests here, looking at deciduous mixed oak, Quercus ilex forest, fagus, pinus, Pisce and or Abies, Betula, Betula nana, steppe, tundra, and glacier. Okay, so you can see how a refugia can get formed in a very hypothetical sense, and how that could affect population of mammals and humans who would depend on it, and whether that would lead to agriculture or continue to support hunting and gathering with foraging and so on, have to be understood in that context of climate response or human response to climate as well. These are the current ideas about general locations of the last glacial maximum refugia for trees in the last glacial maximum, and approximate directions of tree spreading in the early Holocene. Again, important for how ecotones changed. We'll come back to that a little bit later on over Europe, and how they affected evolution of agriculture as well. Okay, so if Levant was the region for evolution of agriculture earlier on, then you can imagine that ecotones and climate probably played a big role in that as well, without saying anything about environmental determinism. So here are the various refugia: southerly last glacial maximum refugia, and the northerly LGM refugia over several parts of Europe here. And the ice sheet would have come down all this way and created these refugia due to various mechanisms of how winds get steered, how precipitation redistribution and ecotone redistributions happen, and so on. Finally, the Noah's flood, which is biblically, I think it's talked about as the Gilgamesh event or whatever. Without getting religious about it, Walt Pittman and Bill Ryan were the first ones to propose that there was a massive flood which created a flooding that was assumed to be global, the Noah's Ark story, and so on. But this infographic from Lapham's Quarterly presents this nicely, so I'll just use that. A controversial theory proposed in 1996 by geologists William Ryan and Walt Pittman postulates that a catastrophic flood off the Black Sea inspired the biblical story of Noah's Ark, the Sumerian epic of Gilgamesh, and other myths. Since then, a lot of work has been done to find evidence for such a flood, and many evidences have been found, so I won't go into those. By the end of the last ice age, around 12,500 BC, glacial meltwater formed huge freshwater lakes, including the present-day Black Sea. Meltwater also cascaded into the world ocean, raising sea levels 400 feet. So it had global impact in terms of eustatic sea level rise, which would have had lots of impacts on coastal habitats, agriculture, marine resources, and so on. Secondly, according to the flood hypothesis, the rising Aegean Sea overran a natural barrier at the present-day Bosphorus Strait. So you can see the pre-5600 boundaries and the post-5600 boundaries of the Black Sea, a massive change including the Sea of Marmara here. Carbon dating of the shells of the first marine mollusks to arrive in the Black Sea dates the flood to 5600 BC. Okay, so that's about 8,600 years ago. Evidence indicates seawater rushed into the Black Sea region at a rate of 200 times greater than Niagara Falls, turning the lake brackish. The resulting flood would eventually have covered 60,000 square miles of land in about 1 year, expanding the Black Sea to its present boundaries shown here. Clearly, that was a massive flood that would have led to many narratives, including the Noah's Ark. Stone tablets inscribed with the Epic of Gilgamesh were discovered in Nineveh, 560 miles from the Black Sea. The flood story in Gilgamesh may be inspired by the Black Sea event. The Genesis story of Noah, which dates to the 9th century BC, is likely derived from Gilgamesh, which incorporates the sources as old as 2100 BC. Similar flood stories are also found in the epic literatures of Greece, India, Burma, and Borneo. So there were definitely global meltwater impacts. Finally, scholars search for clues to confirm or refute this theory. Doubtful archaeologists point to a lack of evidence of Neolithic settlements on the Black Sea and question if flood stories could persist until the invention of writing. So the gap between when the flood happened and when they were written about leaves some questions open. So those are good examples of abrupt climate changes during the Holocene. Abrupt climate changes are still of great interest even in the Holocene because global warming is melting glaciers, and people are always watching to see if the accelerating melting of Greenland glaciers and some glaciers in Antarctica have the potential to create such abrupt climate changes, and how much sea level rise could happen, and so on and so forth. But in the context of agriculture and climate, clearly such massive events, abrupt events, would have had impacts on humans of the time, their life styles, livelihoods, their societies, their ways of life. And then we still come back to the question of whether that led to changes in resources for hunter-gatherers and then drove agriculture. Of course, that's for the younger Dryas. By the time of the Novus flood, 8,600 years ago, obviously agriculture was already kind of around in some places, not as widespread as later on. So all these things have to be put together in a synergistic narrative. Okay.